Hello, welcome to Math 253, Calculus 3 here at Cañada College. My name is Lapuz. We are in section 5.4, triple integrals. In this video, we're doing checkpoint 5.23. They want us to evaluate this triple integral given our B region. And our B region looks like it has limits for x going from 0 to pi. It has limits for y going from 3 pi over 2 to 2 pi, and then our z limits go from 1 to 3. Okay. Now, since these are all constants, I think the setup is going to be fairly simple and straightforward. And we can do it in any order we want. Fubini's theorem tells us that we have constant limits. We can do it in any order. So we'll just do x, y, z. And so we will have a triple integral. Our x limits, or the integrand, is z sine x cosine y. And we'll integrate with respect to x first, and x goes from 0 to pi, and then we'll integrate with respect to y, going from 3 pi over 2 to 2 pi, and then with respect to z from 1 to 3. Okay. Iterated integrals going from inside out will tell us that we're going to integrate with respect to x first. The antiderivative sine x is negative cosine x, so I'll put negative z cosine x cosine y, and to not get confused, we're saying that our x limits are going to go from 0 to pi. So if we put pi in for cosine, I believe that's negative 1, so this is z cosine y times negative 1, with the negative out there makes that a positive, minus negative z cosine y times, evaluated at 0 is positive 1, and so this will give us a positive, 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 so there'll be two of them. It'll be 2z cosine y. Alright, now we're going to take the integral of this with respect to y, going from 3 pi over 2 to 2 pi. And if we do that, we will get the antiderivative of cosine y is positive sine y. So this will be 2z sine y. And we'll evaluate y from 3 pi over 2 to 2 pi. If we put 3 pi over 2 in for sine, 2z is constant. So if we put 2 pi for sine, we're going to get 0 minus, and if we put 3 pi over 2 for sine, we're going to get negative 1. And so this will be positive 1 times 2z, and this will just give us 2z. And finally, we'll go ahead and integrate this with respect to z, and this will give us z squared, and the z squared over 2 will cancel with this 2, so this is just z squared from 1 to 3, and this will give us 9 minus 1, which is 8. Okay, so that should be our result. And again, just following through the iterated integral. One other thing we could have done is that since these are different factors, we can actually write this separately. And I encourage you, I'm just going to start it off over here, but I encourage you to follow through and check out how it's done. We could have integrated this as the integral from 0 to pi of sine x dx, and then multiply that with the integral from 3 pi over 2 to 2 pi of cosine y dy, and then multiply that with the integral from 1 to 3 of z dz, and multiply each of these integrals together, and hopefully you'll get the same answer as 8. Okay, all right, I hope that helps.